Good afternoon.
Good afternoon.
And how's everyone today?
Really good.
Really good. Wow, that's impressive. What's really good?
Why did...
What?
Just everything.
Everything's really good? All right. Well, I'm happy to hear it.
Hey, Mr. Strong, I have a joke.
Okay, let's hear it.
I got it off of Laffy Taffy.
Okay, that's all right.
Yep. Why did the GPS coordinate get kicked out of class?
Why did the GPS coordinate get kicked out of class? Why?
He had a bad latitude.
That's good. That's good. I'll take it. I'll totally take that today. So, a bad latitude. All right. Well, let's see. Everybody there in Mogollon?
Denon's gone.
Who are we missing?
Denon.
Denon. All right. Oh. All right. And everyone there in St. John's and Winslow. So, okay. So let's see. Did y'all get the 3.1 guided notes? Yes. Winslow, yes.
We're getting our teacher right now so she can print them for us.
Awesome. And how about St. John's?
Yeah, we're getting them printed right now.
Okay, great. Well, I was totally late on sending them, so well, not late, but just crazy day, but that's okay. All right, so that is our plan today to start chapter 3. So let's do it. Now, let me give you a little bit of background kind of while we're waiting. Is that, so chapter 3 is on differentiation. And this is sort of like the big cheese for this semester, in fact. I mean, I guess it's one of the two big ideas. But really, everything that we've done up to this point in chapter 1 and chapter 2 is sort of leading us up to what we call differentiation. Okay? Now, so differentiation is, as a matter of fact, they used to, back in the day, when calculus was taught in 3 quarters instead of 2 semesters, this was calculus A, or it was called differential calculus. And this was sort of like the really big idea in the first quarter of the calculus class. And so like I said, everything sort of builds to this moment, to this topic. All right, and so it's sort of like an intro. We're going to talk about tangents and the derivative at a point. So this is 3.1. All right. So remember that we defined the slope of the tangent by this limit. We said the limit as h approaches 0 of the f of x plus h minus the f of x all over h. The subscript 0 you don't have to put in there. That's just saying a specific point. Okay, let me just see what. Okay, so this is the slope of the tangent. Okay, the slope of the curve is defined at that limit. Okay. All right, so when we talked about this, that we used m, okay, for the slope of the tangent. And now I'm going to introduce this notation here, f with a little dash over it. And that means we read that as f prime of x. And so that's the derivative, okay? So the slope of the curve, we're going to call that f prime of x, okay?
Mr. Strong, can you go back to that slide?
Yeah, sure.
Okay, we're good. Thank you.
All right, you bet. Okay, now remember when we talked about average velocity versus instantaneous velocity, we said that the idea of this limit is that if we started off with the secant slope, where we're finding the slope of 2 points, but then we're taking the limit as this point gets closer and closer. So the distance between the points is the h. And so when we take that derivative as h approaches 0, then that's the idea of the slope at that single point. Okay? So let's say we have this function y equals 1 over x. All right? And we want to find the derivative, the slope. Okay? The slope of the curve. So what we can do is say, all right, so if the f of x is 1 over x, then the f of x plus h, in place of the x, you plug in x plus h. Now, what I'm doing here in red is if you have a specific point A, you can actually plug in the point. But for right now, we're not going to worry about that. So whether we just do the function in general or the function with a point, then what you do is you take this limit as x approaches 0 of the f of x plus h, or the f of a plus h, minus the f of a, or f of x, all over h. And so we did some problems in chapter 2 where we had to work out that limit. Okay? Now, so if we're, let's see. Okay, so let's talk about how algebraically, how we simplify this, okay? So again, whether this is an x or an h, or an a specific point, okay? Kind of the way that you simplify this is kind of an algebra trick here I'm showing you here, is if you do 1 times a minus 1 times a plus h over a times a plus h. A times a plus h, you can put in the denominator with the h. Okay? So this becomes that. Now, when we do that and distribute the negative, what's going to happen is the a's cancel. And then the h's cancel, because now h is by itself, it's a factor. And so up to this point, if you tried plugging in 0 for h and calculating the limit directly, you couldn't do it because you get 0 over 0. But once you can factor out the h, then now you can plug in 0 for h. And so then what you get is negative 1 over a squared. Now, that's the derivative anywhere along this curve. Okay, no matter what the point A is. Now, if we know what A is, if we know what the point is, now we can plug it in and say, okay, what about when x is 2? What's the slope? So if we plug in 2, then we get negative 1 over 2 squared, which is negative 1/4. So the slope here is negative 1/4. Well, what if x is negative 2? Then we also are going to get negative 1/4. And so when we calculate the limit, we get the slope of the tangent at any point. If we want to plug in a number for a or for x or whatever variable you use, you can get the slope at a specific point. So this is the slope of the tangent at any point, and then if we plug in a number, it gives us the slope of the tangent at a specific point. Okay? All right, so let's see. All right, now let's say we want to know specifically when is the slope of the, so let's say we want to know where is the slope equal to a specific number. So here's the slope at any point. So if we want to know where is the slope equal to negative 1/4, then what you do is say negative 1 over a squared is equal to negative 1/4. And you solve that for a. Well, another little algebra trick. If you have two fractions that are equal to each other, then if the numerators are the same, then you can just ignore those and just set the denominators equal to each other. And say, okay, that means a squared. So a squared would be equal to 4. So a would be plus or minus 2. So those are the specific values where the slope is negative 1/4 or whatever it is that you're wanting to find. Okay? All right. So see if you can do practice 1, all 3 parts. Now I'm going to go back. So did everybody get the printout yet? Does everybody have the printout? Yes? Okay. So we've all got the problem there. So I'm going to actually go back and let you see this first part so that you can kind of see how to set it up and maybe the algebra trick, and see if you can do all of practice 1. Okay, so David, when you have the answer to part A, so the slope of the curve at any point, let us know. Or if you get stuck. You've obviously got the hardest part there.
Yeah, I'm kind of lost.
Okay, that's fine. That's why we do these practice problems. So, okay. All right. So we start off with, okay, so let's write the f of x. Well, f of x is 5 over x minus 2. So then the f of x plus h, so that means everywhere there's an x, I plug in x plus h. So that's 5 over x plus h minus 2. Okay? So now when we do the limit, okay, the thing you wrote down at the beginning at the notes, so the slope of the tangent, so I'm going to put m equals the limit as h approaches 0 of, okay, here's the f of x plus h minus the f of x all over h. All right? So far, so good? Okay, so now comes the algebra trick that I showed you today. So to subtract these exponents, you take 5 times x minus 2 minus 5 times x plus h minus 2 all over h times x plus h minus 2 times x minus 2. All right, so see if you can pick it up from there, David, and work it out from there. So tell me when you get it or if you get stuck again. All right, you need some help?
Yeah, kind of.
Okay, so here if we distribute the 5 and distribute the negative 5 to get rid of the parentheses, then what's going to happen, and you just leave the denominator alone, don't multiply that out. But what will happen is the 5x's cancel, the 10's cancel, And so all you're left with is negative 5h over the denominator. Now the h's will cancel now because that's the only term, and so h is a factor. So you can cancel the h's. Now you can finally plug in 0 for h. Because up till that point you can't, not until you cancel the h's. But now you can plug in 0 for h. And what you're left with is negative 5 over x plus 0 minus 2 times x minus 2, or negative 5 over x minus 2 squared. Okay? Any questions on that? All right, so then part B says, so this is the slope at any point. So m equals that. That's the slope at any point. So part B says, what is the slope at x equals 1? All right, so Aiden, what's the slope at x equals 1?
Negative 5.
Negative 5. Okay. All right, and then the last part, where does the slope equal negative 5/4? So what's the value for x where the slope is negative 5/4? All right, so Rachel, when you've got it.
X equals 4 and x equals 0.
Excellent. Okay, so again, when you have two fractions that are equal to each other and they have the same numerator, you can just set the denominators equal to each other and solve. So 4 or 0, those are the 2 points where the slope is going to equal negative 5/4. So very good. All right. Any questions on that? Okay. Okay, so to find the derivative at a particular point, you can plug in the number for x at the beginning or the end. So let's say, for example, on the last practice problem, we didn't have to give the answer for part A. We just needed the answer to part B. Then we could actually plug in the number for x at the very beginning, and it actually makes it a little bit easier. Okay, so let me give you an example. Okay, oh, let's okay, so let's say this is my function, and let's say that I want to find the derivative at 4. Okay, so the slope of the tangent at x equals 4, or the derivative of 4. Okay, so instead of doing the f of x and the f of x plus h, I can do the f of 4, which is 2, and the f of 4 plus h. So I'm plugging in 4 in for x. And so it makes it a little bit easier. Okay? So now I set up my limit the same way. I want to take the limit, because this is the, so the slope is the limit as h approaches 0 of the f of 4 plus h, so that's the square root of 4 plus h, minus the f of 4, which is 2, all over h. Okay, so now do you remember from chapter 2, how do we do a limit like that that has a radical?
Conjugate?
Yes, yes, yes. We multiply by the conjugate. And so that's going to be multiplying by the radical 4 plus h plus 2 over radical 4 plus h plus 2. Now, you don't actually multiply out the denominator here, but when you multiply out the numerator, the radical times the radical, the 4 plus h just comes out of the radical. And then the outer and the inner products cancel, and then minus 4, and then don't multiply out the h times the conjugate. So now the 4's are going to cancel. And then I just have h in the numerator, so now I can cancel it with that h. So now I take the limit of 1 over the radical 4 plus h plus 2. And finally, I can plug in. Now, when you plug in, you can drop the limit sign in front. That's when you drop the limit, when you're plugging in. So now I can plug in 0 for h. And so I get 1 over radical 4 plus 2, 1 over 2 plus 2, or 1/4. So that's the slope of the tangent at that point. All right, so any questions before I have you do one? Okay, so let me scroll back up so you can kind of see the setup.
Mr. Strong,
Yes, go ahead.
is that the same thing as finding the derivative?
Yes, yes. That's the same thing as finding the derivative. So the slope of the tangent is the same thing as finding the derivative. Okay? All right, so go ahead and try. I'm going to leave this up, and you try practice 2. All right, so Hannah Z, when you've got it or if you get stuck, let me know. Or if you need me to scroll down or anything, let me know.
I'm lost.
Okay, that's fine. We're going to be practicing this for actually couple of sections here. So it's an important idea, but I know the algebra can get a little messy sometimes. Okay, so here where you have y equals radical x, think of that as your f of x. And now if you plug in 1 from the beginning, then the f of 1 would be square root of 1 plus 2. So that's 3. So the f of 1 is 3. And then the f of 1 plus h, okay? So the f of 1 plus h, so you plug that in into the function, so you get radical x plus h plus 2, or 1 plus h, radical 1 plus h plus 2, when you plug in the 1 for x. Okay, so now, so any questions on the f of 1 plus h or the f of 1? Okay, so now you write your limit. So it's the limit as h approaches 0 of the f of 1 plus h minus the f of 1 all over h. Okay. So again, you can't, when you're doing these, you can't just plug in 0 for h, or you end up with 0 over 0. So you can't do that. So Hannah, what am I going to multiply this by? Well, actually, I could simplify 2 minus 3 and get radical 1 plus h minus 1. 2 minus 3 is negative 1 over h. Okay, now, what am I going to multiply by so I can simplify?
The conjugate.
The conjugate. And so what's the conjugate of the square root of 1 plus h minus 1?
Square root of 1 plus h plus 1.
There you go. Okay? You think you can do it from there, or you want me to keep talking?
I can get it from here.
Okay. All right. So let me know when you've got it.
Okay, no, I got lost again.
Okay. That's all right. So when you multiply out the top, the radical times the radical will just come out of the radical. So you just get 1 plus h. Then the outer and the inner products cancel because they're conjugates. And then minus 1 times 1 is 1. So you get 1 plus h minus 1, and then don't multiply out the denominator. All right, so now your 1's cancel. And then your h's cancel. And so once your h's cancel, then you plug in 0 for h. And you're actually evaluating the limit now. So you drop the limit symbol and you plug in 0 for h. And so then you're going to get 1/2. Okay, Rhett, did you get it? Did you get 1/2?
Oh yeah, I did.
All right, good. Okay. All right, any questions on that? Okay, so you're going to see that as we're going to go into the first problem of the next section, it's the same thing. Okay? It's the same thing that we're doing. But let me just say a couple of things here before we do. Okay? So there are many ways to denote the derivative of a function. All right? And so usually these three that I put a box around are the ones that we use the most. So instead of saying slope of the tangent, if we just want the derivative, we'll either put f prime x, y prime, or dy dx is another notation for the derivative. These other three are used in your book, but not as much. These three are like 95% of the time. But there's df of x, df dx, df of x dx. I don't hardly ever use any of those when I'm doing a problem. Okay. So, let's see. No, that's not it.
Can you go back for one more second?
Yeah, sure.
Thanks. Are those? Okay, thank you.
Okay. You're welcome. I'm trying to find this other. Okay, well, let's do this last. Okay, so it says the following are all interpretations of the limit of the difference quotient. Okay, so some of the interpretations we've talked about are the derivative, the slope of the tangent, those are the ones we've talked about so far. Anyone want to venture a guess as to what else that the derivative might be, the interpretation of the limit?
Continuity?
Okay, continuity is part of it, but no, it's not continuity. But good guess. All right, well, we'll get to some more. But for right now, That's what we're talking about. Okay, so now I just want to just make the transition to 3.2, and because we're really keeping on talking about the same thing here. So the derivative as a function. So the definition of the derivative, the process of calculating a derivative is called differentiation. So that's what we've been doing today, is differentiation. So if the problem says find the slope of the tangent, find the derivative, find f prime of x, it's all the same thing. You do the same thing. So here, if it says we calculate this limit, okay, for any of those directions. All right. So, actually, let's just go to this one. So it says differentiate. So doing the same thing that we just did in 3.1, see if you to do the limit as h approaches 0 of f of x plus h minus f of x all over h. So see if you can do it for this one. All right, so Rhett, when you've got it, or if you get stuck, let me know. Now, just so you know, in about a week, you'll be able to do this type of problem in your head. Believe it or not, you will. Maybe a week and a half.
Is it -1 over x minus 1 squared?
Ding, ding, ding. Great job. Great job. And if you got that, you are going to be in really good shape for this whole chapter. Okay? This is good. This is a big idea. Okay, so let me just go through it here. So here's the f of x plus h. So you replace x with x plus h. So 1 over x plus h minus 1. So then the limit of f of x plus h minus the f of x all over h. So now you do 1 times x minus 1 minus 1 times x plus h minus 1 all over x plus h minus 1 times x minus 1 times h. I usually put the h in front, but it doesn't matter. All right, so then when you distribute the negative, you're going to get negative x minus h plus 1. And then the x's are going to cancel. The 1's cancel. So all you're left with is negative h over the denominator. The h's cancel, so you get negative 1. And then you plug in 0 for h, and you get x minus 1 times x minus 1, or negative 1 over x minus 1 squared. Okay? So, beautiful job, Rhett. All right. So, we'll be practicing some more, practice with those problems. And that's kind of where we're going to go from, work from there on Monday on 3-2. So, anyway, thanks you guys for working hard. Everybody was working hard today, and I appreciate it. And we'll see you Monday. Have a great weekend.